So if I take a look at this problem now, I'm dividing and I have complex numbers. 3i, remember, is 3 times the square root of -1, which you're not allowed to have in the denominator. You can't have 3 times the square root of -1. So you have to get rid, you can't have that square root of -1. So you have to find a way to get rid of the I. Okay, before I do that, if you take a look, notice we have 9, 12, and 3. I can reduce all of those numbers because 3 goes into 9 and 3 goes into 12. So 9 divided by 3 is 3. 12 divided by 3 is 4. So I have 3 plus 4i all divided by I. Well, I is the same thing as the square root of -1. So how would you get rid of the square root of -1? By multiplying by the square root of -1, which is just I. So how am I going to get rid of this I in the denominator? By multiplying it by I. Because the square root of -1 times the square root of -1 is just going to be -1. And if I multiply the bottom by I have to multiply the top by I. So my denominator becomes I times I is I squared. And remember, I squared is just -1. My numerator becomes 3 times I, so 3i, plus 4i times I, which is 4i squared. And remember that 4i squared, that I squared just changes it. So it's 4 times -1, so it's not going to be a plus 4 anymore. It's going to be a minus 4. Well, I can clean this up a little bit. Instead of saying 3i minus 4, remember, the I has to go at the end. So I'm going to rewrite that as -4 plus 3i divided by -1. And the -1 just changes the sign. So it's actually a positive 4 minus 3i. Because if I divide by a -1, it just changes those signs to switch. And that's it, 4 minus 3i. So if I take a look at the next one, it gets a little bit more complicated because I have not one thing in the denominator, but 2 things in the denominator. And this goes back to last unit. Remember, if you have 2 things in the denominator, you have to multiply by 2 things in the denominator. That conjugate, back to this problem, if I have -6 plus I times -6 minus I, because they were opposites, the i's went away completely and I was left with 37, which is what I needed, right? A number without I. So that's what I'm going to do in this case. I'm going to multiply by 1 plus 4i on the bottom and on the top, and that will get rid of my I. Because remember, I is just saying the square root of -1, and you can't have the square root, or you can't have radicals in the denominator. So I times I, or 1 times 1, not I. 1 times 1 is 1. 1 times 4i is 4i. -4i times 1 is -4i. And -4i times +4i becomes -4 times 4 is 16i squared. And remember, I squared just means, instead of saying minus 16, I squared just changes that sign. So now it's going to be a plus 16. That cancels. And I have 1 plus 16. What's 1 plus 16? 17. Hopefully you said that. Or at least you thought it. But now I have to do the numerator. So 1 times 2 is 2. 2 times 4i is 8i. 3i times 1 is 3i. And 3i times 4i, well, 3 times 4 is 12. Positive. I times I is I squared. I squared just changes the sign, so it's not going to be plus 12 now, but just a minus 12. And then just combine like terms. So 2 minus 12 is -10. 8i and 3i makes 11i all over 17. And there's nothing to clean up with that, so that's it, just like that. And then for the last one, I have 2 things in the denominator, so I'm going to multiply by 2 things. If you just had 3 plus 4 in the denominator, 3 plus 4 is 7. There's no radical. That would be great, but it's not that. It's 3 plus 4i, which means I have to multiply by 3 minus 4i. There's no radicals in the denominator, on the bottom and on the top. And when you're multiplying these, I'd like to draw the lines, but if you wanted to, you could just do a box and think of it this way. 3 and 4i, 3 and negative 4i. Remember, to get inside the box, you multiply. So 3 times 3 is 9. That becomes 12i. 3 times negative 4 becomes negative 12i. And negative 4i times 4i is negative 16i squared. Well, negative 16 just changes to positive 16 because I squared is just negative 1. That cancels, and 9 plus 16 is just 25. And then I have to do my numerator. So 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2i times 3 is negative 6i. And negative times negative makes that positive 8. I times I is I squared. Well, I squared just says, nope, not positive anymore. Make it a negative. So what's 15 minus 8? 7. What's negative 20i minus 6i? Negative 26i all over 25. Now, if this had been 5 minus 25i all over 10, I could reduce those numbers because 5 goes into everything. So I could have changed that to 1, 5, and 2. But right here, there's nothing that can be taken out. So you leave it at that and you're done. So complex numbers is really similar to polynomials, but just remember, I is not a variable, it's actually a number.